So my name is Stuart Halloway, and I'm going to be talking about power. I have the advantage of T-shirt design to back my play. And for those, how many of you were here last year? Right. Wow, that's a terrific. I think everyone's back. I think every single person is back. Pretty cool. So last year I talked about simplicity, and sort of my goal in talking about simplicity was twofold. One, I think it's a terrifically important principle in software design. And second, I wanted to antagonize Rich into saying something even better about it. So I feel like sort of mission accomplished on both fronts. So we'll see how things go this year. If anyone's trying to guess what I might talk about next year, the circles are kind of a dead giveaway. And in fact, the game plan for these kind of talks is sort of given as well. If you want to know what the word power means, you could always, do worse than starting with the dictionary. So power eventually works back to the Latin, and it means to be able. That's pretty good. When I'm writing software, I want to feel powerful. I want to feel able. How many people would say they feel powerful when they're working in Clojure? That's a great feeling, isn't it? It's a terrific feeling. It would be nice, though, to have some rigor around what that means. And I think that Rich has done a great job of putting rigor around the word simplicity and putting it into an objective box separate from easy, which is in a much more relative box. And so I'd like to do the same thing today with power. Well, this definition of power is the etymological basis, but you could also look to the sciences. So if you're an electrician, there's actually an equation for power. And you know what people say, it's not the V that gets you, it's the I, right? And there's also an equation in physics, and it actually comes down to the same thing, right? It's literally the amount of work you can get done per amount of time. Amount of work you can get done per amount of time. And this is an important elaboration on the notion of feeling able. Right? If I told you I could build a pyramid in 10,000 years, you wouldn't think that I was very powerful. If I told you that I could build a pyramid in 30 seconds, well, that's right. You have to specify, right? That's the delta W, right? The delta W matters, and the delta T matters as well. So power is work per unit time. The other thing that you'll find out if you look at those definitions from electricity and from physics is that work is directional. Work is towards something, and by implication, not towards all the other compass points. Right? So when you're working, you're going somewhere. And if that's not where you want to be going, then working is not necessarily helping you. Right? The old work smarter, not harder sort of notion. So that's the English language and the science basis for the word power. What about what computer scientists say about the word power? I have to say that I feel like I'm in amazingly elite company being in this room full of people. Right? I don't feel like I belong here. I keep looking at myself and saying, should I really be allowed in this august company of great thinkers? And in enumerating expressive power, which is what I'm going to talk about right now, I feel like I finally found something where I can contribute to moving the frontiers of computer science forward. It turns out that nobody has actually categorized fully, in my mind, what expressive power means in computer science. And there are, in fact, 7 hard categories of expressive power. And some of them have been investigated to some degree by academics, and others have been relatively ignored. Probably the most common continuum of power is, in some ways, the least useful one. It's the one that tells us that all of our programming languages land at about the same place on the power spectrum, which is which one of these? What do we actually program in? Who works in finite automata all the time? No? Okay. Anybody work with a Turing oracle on a regular basis, right? Where do all of our programming languages land us? Turing machine. Right? So that's one of 7 sort of axes of power that you might look at. And as you move down this list, you become more powerful, and I'm going to start using the word expressive for this, in terms of things you can express, or things, in this case, things that a language or grammar might recognize, perhaps. There's another one, the sort of functional power curve. If you work your way, you could start with the very austere lambda calculus, and you could work your way up through a series of different enhancements to the lambda calculus, and end, of course, in the end zone, which is clearly Hindley-Milner type systems, right? That's as good as we can get on the functional power axis. Or you could take the logic power train, and you could look at different orders of logic and talk about, well, you can express that in a first-order logic, but you can't express it in a zeroth-order logic. Or you can say that in Prolog, but you can't say it in Datalog with negation. Now, some of you may not be familiar with Datalog with negation. That's also knowable by its legacy name, which is the relational model plus recursion. Or you could talk about model power. There's this great book that breaks out different models of programming by saying we have this basic purely functional declarative model on which we can add a few concepts, data flow variables, laziness, and cells, and you can mix and match those things, each of which gives you additional power. One of the things I really love about this book is that they have this picture that's showing all these different kinds of power that you might have that puts Haskell in the middle of the power scale. Wow. So there's all these things that are more powerful, arguably, by this definition than Haskell. The fifth kind of power in computer programming is poetry power. And poetry power has to do with what you can say in a poem. And you have really unpowerful poetic styles, like the sonnet, right? Because the sonnet does really limits what you can say. And on the other hand, by far the most powerful poetic style is what? Free verse. It's not limited at all, which is why Robert Frost, in poems like Mending Wall, is far more powerful than a Shakespearean sonnet, for example. The sixth kind of power is music power. And again, computer scientists don't spend nearly enough time thinking about this one. I'm not sure why. But you look at the trombone, and you can say, you know, the trombone is strictly more powerful than the piano because of its ability to play tones, semitones, and tones between tones, right? Because you have a slider. Whereas the piano is relatively more limited to things that are right on the pitches on the scale. On the other hand, the guitar is definitely more powerful than the trombone because it can play more than one note at a time. Yet, on the other hand, the piano is clearly more powerful than the guitar because it has a broader range of notes from bottom to top than you can play on a guitar. And what you realize is that these power scales start to end up feeling like rock, paper, scissors, lizard, Spock, which is the final power scale that I'm going to offer, right? X is more powerful than Y, is more powerful than Z, and where do you end up? And the result of this is that if you look at people talking about feeling powerful in their programming language, you sort of run afoul of this notion of expressiveness versus this notion of getting work done per unit time. And let me just be clear. I'm going to come down in favor of getting work done per unit time. Right? That's where I want to go with power. But the conversations in software are about expressiveness. Expressive power is kind of redundant. Right? If you're sufficiently, what does the word power add? So I may just use the word expressiveness the rest of the way. And so where do we go wrong in talking about expressiveness that doesn't allow us to translate that into some reliable, objective, shareable conclusions about actually feeling powerful and getting work done? Well, the first problem is we're talking about delta W, delta T, but whose time? Whose time do I care about? Right? Here are two equally powerful representations of the number 42. As a programmer, which one of them do you want to work with? No, but which one did you mean when you said that? So, and what you come up with when you start thinking about this, and this is where people sort of punt and go, well, I'm going to use the word powerful to describe what I like. And we're going to agree that all the computer programming languages that we use are Turing equivalent, and so we don't have anything to say. And in fact, there's this notion of a Turing tar pit, right, which is a programming language which is Turing complete, but which is so irritating, right? It's deliberately designed to make you feel not powerful in the sense that I'm talking about. Like you are unlikely to be able to have a good delta W over delta T. Now, this is a Hello World program in a Turing tar pit language. I'm going to count to 3, and if you know the name of this language, I want you to shout it at the top of your lungs. 1, 2, 3. All right. See, I didn't swear. So when you think about time, you really think about programmer time versus computer time, right? If the computer can do a lot of work, so I don't have to do very much work, that's often going to be a really good trade-off. And in fact, I love this, the actual definition of a machine is something that manages power to accomplish a task. So when we're using machines, a machine is something that redirects power, right? It changes the direction of a force to help you accomplish a task. And I think equally important to us, I mean, still, even in this picture, this is a nice cigarette rolling machine, we still care about who's standing at the end turning the crank, right? We want the power source not to come from us either. The second question is, what direction is your power taking you? All of the different notions, those 7 notions of expressiveness that I talked about, are power in some direction. But are they power in the direction of some application or program that you're trying to build? I want to think about the number of times that I was building a web application and my stakeholder said, you know, the users really like this, but I'm not sure if the type system in your language is decidable. So it just doesn't come up very often, right? Ditto for any of the other things that have to do with power that we would talk about in an academic setting, right? Likewise, nobody ever asks me to perform a poem or play Sunburst Jubilation on the guitar, which I may take a year off of my life at some point and try to do, but not today. It's also the case that even people who are capable of working with the most powerful, in the expressiveness sense, things, actually don't necessarily love it. So Robert Frost famously said, writing free verse is like playing tennis with the net down. That doesn't sound like a powerful feeling necessarily. That sounds more like a dancing on thin ice kind of feeling associated with power. And in fact, and this is a really good piece of news because sometimes we have problems in the industry that haven't been resolved by the W3C, but it turns out that they have actually solved the power problem with this piece of advice. When publishing on the web, you should usually choose the least powerful or most easily analyzed language variant that's suitable for the purpose. I didn't even know there was this whole thing where they just had findings. Right? There are these W3C findings, and so this is one of their findings, which is power is bad. So, why is power bad? Why would power possibly be bad? Well, power, it turns out, is in many cases going to be something that might potentially limit your ability to compose things or your ability to reason about how things are going to work. If you made a laundry list of things that made it to the status of an X considered harmful essay, these are all things that are, strictly speaking, things you could talk about in terms of expressiveness. I'm sorry, your language sucks. It doesn't have the expressiveness to say go to. Oh, your language sucks. It doesn't have the expressiveness to allow you or force you to do explicit memory management. Right? Those are all expressive powers. Those are all things that you can say. Do you want to say them? I don't know. That's the hard part, right? It turns out that feeling powerful as a developer comes from being able to combine and sometimes constrain these various expressive powers. Not always constrain. I'm not saying that we can never play tennis without a net. Right? Sometimes you want to play tennis without a net. You want to use the most powerful thing that's hard to compose with other things and does all kinds of nasty stuff. So what does Ousterhout's dichotomy have to do with any of this? So Ousterhout wanted people to use Tickle instead of C. And as part of his marketing campaign for that, he laid out this distinction between two kinds of languages. On the left here, you have languages really dominated by C at the time that have a set of characteristics. They're static. They allow you to do arbitrarily complex things with data structures. They're compiled. You use them to write independent programs. And then on the right side, you have dynamic languages. And when Ousterhout made the original argument, these languages tended to have limited data structure capability. They were interpreted, and they were used for glue code. And there are languages like Tcl and Ruby and Python. And so I would ask you, where on this hierarchy should we put Clojure? This is one of those Zen questions that needs to be unasked. Right? This is a crummy hierarchy. And what's wrong with it? Well, anybody who saw the simplicity talk, what's wrong with this? Either my talk or Rich's simplicity talk. What are these things? These are two big compound things, right? This characterization of the world that's divided things sort of into two categories, which it may be the case that there's a matrix here and that every possible spot on that matrix might be occupied by some language or some tool. So in the time since this idea was first pushed, we've had some newer thinking about what it means to be powerful. And there was an essay that certainly influenced me a lot, Paul Graham's essay, Revenge of the Nerds. This is the one where he enumerates 9 powers that Lisp has. And if you look at those powers, I've sort of grouped them here so that the 7 powers on the left are things that really a lot of programmers have access to today. And the 2 powers on the right are powers that are still somewhat exclusive to Lisp. We could augment this list. Right? This doesn't have to be our list. And if I were going to start augmenting this list, this is actually not my purpose today, but just a few things that I might throw in there if I was talking about capabilities that Clojure adds over the ones that Graham enumerated. Certainly programming with values and a model for identity and time. You might want to talk about polymorphism, and there are probably a lot of others that you could put in here. And all of these powers are abstractions that you use when you think about how to make a system, right? I'm trying to do this. I'm going to align recursion and dynamic typing and garbage collecting and expressions. I'm going to compose those things together in order to solve my problem. And if those things provide a nice basis for work, I'm going to feel powerful. If they don't, less so. So how would we measure a stack of these? I mean, presumably we could make a list of these for some other programming language or some other style or some other environment. How are we going to make that list and have any useful basis for comparison? I have 3 possible proposals for that based on reading what other people have said and thinking about it some. The first one is concision. If something allows you to express yourself briefly and someone else has to do the same thing in a much more elaborate way, then you're winning. A trivial, goofy example was my 0 versus 42. Right? That kind of I have to do something really long to get some work done. And in fact, that's the argument that Paul Graham makes in a separate essay where he basically says, I think that maybe concision is power. Right? Just full stop. Another way to look at it, though, is having something to do with locality. If I have a program that does something, and in order to take advantage of, or if I removed a feature from the language, I would have to reorganize the entire program. In other words, there wouldn't be local changes. It wouldn't be just, we've picked a longer or a shorter keyword for something. But I couldn't even organize my program the same way without this thing. Then we'd have a problem. A possible good example of this would be if we took Clojure and removed the identity types. Right? So we remove all the identities and say, Clojure is going to be purely functional except for interop. And if we did that, it's Turing complete, right? You could still write the programs you're writing today, eventually, but you would have to reorganize your programs. You couldn't make a set of local changes one by one throughout your thing. It would be the kind of thing that drives you crazy in the OO world where you talk about it in terms of encapsulation. Right? It would be a pervasive change to deal with it if that feature was removed. And finally, simplicity in the sense that a set of powers are taking you in a direction, and if a power is complected, then it's taking you in more than one direction at once. right, by definition. And that may not let you go as efficiently as you want to go in the direction that you want to go. I could talk for a whole hour about that alone, but I feel like the simplicity talks are already out there. And I think that that's a part of that point, right? The simplicity makes you feel powerful because you are going exactly in the direction that you want to go when you're using simple tools. Now, it's not really clear whether Paul Graham's list of powerful things works for anything other than selling one startup to Yahoo stores. But in the time since then, we've kind of had this revenge of the glue, where a couple of things have happened. Certainly it's the case that these glue languages are now used to write full independent programs. Right? People build applications in Python and Ruby and PHP and so forth all the time. And these languages have picked up all manner of object-oriented or data structure capabilities and features. And so it might be tempting to, well, first off, you say, if anybody finds a really good picture of a glue monster, I would really love to add it for this slide. We can go back and do that. I could not find a picture of a good picture of a glue monster on the internet. But I love that, this notion that we're building all of our programs entirely out of glue. There's no wood or cement or nails or anything in them anywhere. So sort of the question is, first off, in some ways, Ousterhout has won. Paul Graham has won. People are building with a set of more powerful abstractions than we often had on our tool belt 10 years ago. And we're moving more and more, arguably, towards these glue languages. And so it pays to ask what we've lost. What's missing from this world on the right side here? And I think that one of the choices that you end up making there is that you say, you know what, I'm going to write my system this way, or I'm going to write the application part of my system this way, but the entire system is not going to be written in one of these languages. Right? What's not going to be written in Ruby in a Rails app? The database. Right? The database probably, the message queue system. There's all kinds of critical performance subsystems that are not going to be written. And conceptually, what you do when you're working in a higher level language that doesn't have some urgent capability you need for some tiny part of your application is you can jump out to a foreign function interface. And I think of a foreign function interface as being this way to dodge bullets. Right? And it's awesome. Right? This is not an unviable way to build software. Quite the opposite. Right? It's entirely viable to say that 90% of my work is doable in this very expressive, very close to the problem domain, high-level language, but 10% of my problem isn't doable there. And that number will vary depending on what kind of thing you're working on. And I can get to that through a foreign function interface. Now, we've gotten all distributed lately, so sometimes that foreign function interface is now more of like a JSON service or something, but conceptually it's not different, right? We can punt some part that we're not able to do over to the foreign function interface. So, what's not glue? And this is where I think that Ousterhout's dichotomy stays with us and causes problems. And I mean, most of this stuff has all kind of gotten fuzzed and munged in people's heads and doesn't matter. But we are left with this notion that what you need to build the hard stuff is a static compiled language. And that presumption is borne out by a lot of applications where the relatively easier parts are built in dynamic languages, but they eventually call a database that's written in C or so forth, right? So there's anecdotal evidence for this perspective. But if you think about what makes a platform powerful, if you enumerate the capabilities of, say, the Java platform, what does the Java platform have? What is it made of underneath? You have classes and interfaces and primitives and bytecodes and core types that are in the system, right? You actually want to be able to use the types that are provided, maybe library things. Is there anything in any of those things that requires static typing or a specific model about how compilation or interpretation happens? No. Right? It's a historical fact that a lot of systems that give you direct access to platform capabilities do so through languages that are statically typed and compiled. But that doesn't have to be the case. And so Clojure aims to provide full platform power. I mean, Rich has already pithily summarized this in the past by saying, I didn't write Clojure to replace Ruby in my day job. I wrote Clojure to replace Java in my day job. And the aspiration of Clojure is to say that we do not have to dodge bullets. Right? We want to have the full power to control the matrix. So, how does this help? That's a nice 25 minutes while I drink a beer and just ramble on about power. What does this help you do in thinking about what's happening in the Clojure world? It helps you, I think, when you're learning Clojure to understand that this is a goal, because it explains things like these paired APIs. Like there's some API that represents an abstraction that we want to use, reify, and then there's some other API, proxy, that looks like this sort of ugly, mutant side version that doesn't have all the same beautiful characteristics of reify. And what's going on there? When you see those things, they are often about accessing the platform. Right? We still want to be able to access the platform and ask the platform to do things, even when those things don't fit our notion of simplicity. Right? If the Java platform and all its primitives already were, in our view, simple, then the things that Clojure built on top would entirely be thin, superstructure-y type things. And so, to the extent that you believe that Clojure's approach to simplicity and the things that it calls out in that fashion deserve to be so called out, if they're not mirrored down at the level of the platform that Clojure's running on, you're going to see some ugliness down there, where there are forms that are designed directly to target that. Likewise, this helps you see why things like protocols and def type are a priority. Right? Protocols and def type let you write Clojure in Clojure, which is a great example of having a guarantee that you have sufficient platform power. Right? If you can write Clojure in Clojure, that's pretty good evidence that you actually have good access to the platform. Probably the one that people ask the most questions about is this also explains the 1.3 numeric changes. And I'll take that separately in a moment, so let me come back to that one. It also explains, and this one is one that people miss a lot when they're learning Clojure, the complete absence of wrappers in Clojure. Right? Clojure does not wrap string, it does not wrap primitives, it does not wrap Java classes in general, because once you're in that game, you're automatically in a world where there's a layer below you that you need to go to if you're actually targeting the platform. Part of the reason that this is confusing is that people use the word wrapper very casually. I'm talking about putting something around something and claiming that they're both kind of the same thing, which happens a lot in some other languages and is anathema in Clojure. There's also, people use the word, like Stuart used the word wrapping this morning casually to talk about wrapping a pushback reader on a buffered reader. Those kinds of things, that's not the kind of, if we're going to use the word wrapping for that, we're going to put some asterisk beside it and say that's not necessarily the same kind of thing. That also may just be required by the fact that we're on the platform in that case as well. Understanding that power is a design goal of Clojure, and I'm going to use the word platform power to talk about this, also helps explain what's happening in Clojure versus ClojureScript and what differences you might expect to see there. When you think of Clojure in terms of the abstractions that face the programmer, right, all the beautiful things that we compose together to make systems, then every new dialect of Clojure is going to provide the same ones, unless they cannot be delivered on the underlying platform, in which case they just won't be there. Right? The last thing you want to have happen is have an API that sort of looks like it's doing the same thing, but not. This also may help explain why I want to take my code and transparently take it from here to there is not a goal. What happens to platform power if you make that your goal? Right? If we said, the biggest thing about Clojure and ClojureScript and Clojure on the CLR was you're going to take full programs and just drop them from one place to another and have them run, you immediately have bought the game of building a bridging layer underneath, and now you're no longer targeting the power of the platform. It also explains the one place, in my view, where Clojure deliberately has compromises with simplicity. Right? If there is something that the underlying platform presents that might be needed to write an application that achieved maximum performance or parity with Java, and that thing isn't simple, then it may be exposed. Right? Because that thing needs to be there. It needs to be there to do things like writing Clojure in Clojure. Now, let's talk for just a moment about the numerics. So, Clojure has always had, or for multiple releases, as long as I've been involved with it, has always had all three different ways of thinking about numbers. The unchecked way, which is the way Java works, right? Party on, add numbers together. If they overflow, stuff happens. The promoting way, which says, we're going to use numbers, and if you add together a long and it gets too big, we'll magically promote to a big integer. And the checked way, which says we're going to approach the speed of unchecked ops, but we will throw an exception if you get in trouble. A lot of people, a minority, but a non-trivial minority, really liked promoting being the default. Why did they like promoting being the default? It made the Fibonacci demo really easy. Right? Promoting, if we have the promoting math, then the Fibonacci demo is super easy. But what's the real problem here to begin with? What puts us in this boat is the lack of some kind of fixed num on the JVM. Because, when I first thought about this, I really thought about the speed column, right? The promoting versus checked being about the speed column. But it's really equally about the type column. Right? Java can work with primitives. If you're going to have a language that's going to do everything Java can do, that language has to be able to work with primitives. If that language starts working with primitives at any point, then you have to accept that only one of two things can happen if you overflow. Right? Because your type signature constrains you. As a developer, you don't see this. Right? The developer, you're not looking at the type signature of whatever the compiler is making eventually under the covers. But in that implementation detail, you have to make a choice. And if you're going to allow the representation of primitives, and if you're going to allow it to be fairly pervasive and get performance benefits from it, then you have to make the choice that Clojure makes in 1.3. Now, the good news is that from an expressive power standpoint, nothing has changed. All capabilities were present in 1.2. All capabilities are still present in 1.3. What is the default is a little bit different. When we made this change, we tested dozens of open source projects running their test suites against the change. Guess how many things we found where you needed to have more than 2 to the 63rd things? Testing across 20 different projects. Guess how many bugs we found? Nada. This is not to say that you don't want to have promoting math in some cases. And this is also not to say that this doesn't have the nature of a trade-off. But it's a trade-off that is easily understandable from a background of we don't want to make the Clojure is out of bounds for certain kinds of application development trade-off. There are a few instructive exceptions to the power rule. So one thing you could say to quibble with me about this is to say, well, I can write a Java program that will emit a stream of bytecodes that you cannot make a Clojure program emit. Right? So there's not full fidelity in that sense. Every single thing that gets added to Clojure passes through the filter of somebody thinking it's important enough to do, which is not just about, ooh, this is good. It's also about it's worth the cost and it's worth the engineering effort. One of them that has come up recently for me is creating of interfaces. If I'm going to create an interface, right, there could be a really awesome, fleshed out def interface form in Clojure that had all the capabilities of Java's interface declarations. It would take somebody some work to make that, right? So the cost of introducing that into the universe is non-zero. What would the benefit be of having a way to declare interfaces in Clojure that had full fidelity to everything you could say while declaring interfaces in Java? Not typing it in Java. Right? And that's really it, because the only thing that Java is actually concise at is interface declarations. If you look at it, every single word in a Java interface declaration is actually required and actually means something. There's no, you must fill out this form in triplicate anywhere in an interface declaration. But also ask yourself, when you're writing an interface declaration, what are you making? A header file. You're making a header file for someone to consume. And we're trying to convince the 99.74% of people who are still using Java as their primary JVM language to consume our jar file. Who wants to hand them their header file as a Clojure file and say, oh, Clojure's not different at all, you can just use this jar file, and then there's this thing all surrounded with parentheses as their header file. Right? The interface is the last place in the world that I want to make Java not look like Java. I want it to look exactly like Java. And I'm absolutely willing to type that in. In fact, even if it was ugly, I would be willing to. I want to be able to hand that to people and say, look, it's no different. This is exactly the same thing you would have consumed if I had written the library in Java to begin with. Of course, there won't be any methods with the name set on them, but at least structurally it will be the same. There are some details of implementation inheritance that can't be duplicated in Clojure. Implementation inheritance is evil. If there was a compelling reason to make it available in Clojure, then somebody could go and investigate that and propose doing the work. There hasn't been. There are bytecode operations for manipulating integers, separate from longs. Those are currently not directly supported. And again, there's no use case evidence that there's a performance win, and there is an engineering trade-off. Right? There's work that has to be done to make that happen. It's possible that you might agree with everything that I just said. I actually don't agree with everything that I just said. I try to insert about 20% outright lies. But it's possible that you might agree with everything that I just said and still not feel very powerful writing Clojure code. There are still some things that you could trip up on. For example, the library ecosystem certainly makes you feel powerful to the extent that it works. But there are a lot of questions there. Does the library that does what I need to do exist? If it exists, how do I find it? How does it work? How do I deploy it? Who can improve the answers to these questions? And this is an example of a category of questions that I might summarize as, okay, Rich, we got simple and power, but can we please have just a little tiny bit of easy somewhere? Just a smidge. And I'm just spitballing here. Maybe some error messages. Maybe some more sample code. Maybe maybe some better story for, I push a button and my code is magically on the internet 5 seconds after I decide what my business model is. Maybe we need to have a more beginner-friendly environment. And the cool thing about this is that if simplicity and power have been done well, where do the answers to most of these questions actually live? And if you think about it, I've actually got these sort of broken out. Feeling powerful might come from expressive power. It might come from expressive power from the language core, so working with pure functions and persistent data structures. It might also come from the expressive power of some awesome library like core.logic. You're going to feel powerful if you have platform power. Right? So you have the ability to access everything you need on the platform. You don't have to go foreign function interface to solve your problems. You're going to feel powerful if you have libraries there when you need them. And you're going to feel powerful if there are all kinds of creature comforts in play. The red things on this slide represent things that still bottleneck all the way through Rich before they change. And this is a good thing, and we should all thank him for it. It's an awesome thing, right? That if anybody wants to live in a language run by a standards body or a committee that's voting, there are plenty of them out there. But the core, and this is things like, we're going to add mutability, right? So those kinds of core decisions. And how we reach the platform, so how are numerics going to work? Those things ought to be very carefully scrutinized by a large number of people and change relatively slowly. On the other hand, there are some kinds of power, even core conceptual power, like logic programming, that may be able to get substantially done at the library level. Certainly, libraries are all done at the library level. And there are a ton of creature comforts that can be done without touching core and without pushing any of the platform issues. One particularly important thing to think about here is, can we offer creature comforts that are separate, that are logically distinct from the deployment environment? I mean, Paul Graham said the whole language there all the time. That feels really awesome, but what I'd really like to have is the badass, streamlined production version of the language there when I'm in production, and the incredibly comfy Barcalounger, super-duper error messages version of the language there when I'm doing development. And there's no reason that a lot of those tools can't exist. And the simplicity of Clojure makes it very easy to experiment with adding those things. Right? The REPL lets you plug read, evaluation, and print. You could very easily go and make a creature comfort environment that doesn't require any kind of scrutiny or oversight or consideration at the level of, oh my God, this is a change to the core. And so I'd like to end today by saying that if you're looking to have a powerful experience in Clojure, please come on up and join us on the latest releases. Please move to 1.3. Please come on to the 1.4 alphas. Those things are being watched regularly. If you have an issue, it can be fixed quickly. They're not substantially different. We don't have a high rate of bugs coming up or anything like that. It's a single character or two in Leiningen or Maven to just say, you know what, I'm going to get on the latest stuff and get access to the latest and greatest power. And ask yourself, what can we, this whole community, do to make Clojure easier? I think we've already nailed simplicity and power. I think Rich has done, and the community has done, an amazing job of tastefully putting this language together. And we're now at a place in the adoption curve where it's definitely reasonable to think about making it easy. And the first step to that is creating a world where adding comforts is parallelizable. Right? It does not have to bottleneck through changes to core. And we are there. It was not fun, Stuart Sierra will tell you, doing all the work to get modular contrib. But now it is very easy for somebody with a good idea to say, you know what, I want to make a new contrib. I'll be in charge of versioning it and releasing it. I don't have to be coupled to what the language is doing. And we've already had great success and people really taking off and moving things forward. Big thanks especially to Sean Corfield for the work that he's done in helping people move to 1.3. And it's wide open now, right? If you want something in Clojure, I challenge you to go make it. And I can tell you that the Clojure dev, everybody else who works dev, and Clojure core, the business part of relevance that does boring things like running the server for Jira and things like that, will do everything we can to stay the hell out of your way and let you make stuff and help you have a place to put it. Thank you very much. Have a great evening.